Okay, so thank you all for joining us for our session B, the second of 4 sessions for our fall conference. I want to introduce Alicia McCarthy, who's going to be running the show for this session. Alicia, as you know, has been with TURI for 6 years or so now. She's our extraordinary lab person, really great at working with companies to help them find solutions. She's also been expanding her skills to incorporate sanitizing and disinfection into the suite of capabilities that the TURI lab has. So we're really happy to introduce Alicia. I'm going to be monitoring chat and anything else. So if you have a question about, if you're having technical difficulties while we're going, you can chat with me directly, and I will try to take care of things. Alicia, I'm going to let you take it away.
Sounds good. Hello, everyone. Thank you so much for taking the time today to come to our session B on TUR Success Stories. We have a really good group of people that are going to tell you some of the case studies that we've been working on with them to find safer alternatives.
And Alicia, if you could just speak up a little bit more loudly, that would be good.
Before we actually get into that, though, I just wanted to do kind of a brief overview of who we actually have here from TURI that may be talking or could provide some answers for you if need be. So Jason Marshall, our lab director, is on this call as well, that you can reach out. Myself, I'm the laboratory specialist. And then we have Gabriel, who just started as our green chemist. And then Amelia is actually a student that will be talking a little bit alongside with Cedar's case study. And she is a research assistant coming up in the next semester that has been with us for a while. And we'd like to specifically thank our guests. So from SE Shires, Barry, and Cedars, we have Chuck, Brian, and Lisa. If you can for a moment, please put in your name and affiliation into the chat if you're interested, just to kind of let us know where you're coming from, and that way we can have that beyond just the registration. So I'll let people kind of do that at their own. For this session specifically, I'm going to be providing a brief overview of the TURI lab update, what we've been doing lately. You're also going to hear from Gabriel, and you're going to hear a little bit from Amelia. And then a majority of what we're going to be doing today is hearing from the companies, because the case studies are the most important part. And then we're really going to open it up for panel discussion, and just get ready with your questions, because we want to help you as much as possible to make this session worth your while. So for the TURI lab update, right now we've been really trying to focus on expanding those sector opportunities and seeing where we can provide the most assistance. And still, surface cleaning is a major area that is in need of safer alternatives, specifically for halogenated solvents. We are actively trying to search for opportunities to branch out and help those hard solutions that don't have anything out there readily on the market or may need further research. So if that's you, definitely feel free to reach out to us. Or if you're currently working with OTA, feel free to let them know that you're interested in reaching out to us, and we can actually then you can actually then have them reach out to us as well, and we can partner there. We've tried to find some new solutions, specifically using what is known as Hansen solubility parameters in practice, or HSPIP. You may have heard about this from our previous conferences that we've talked about this. We've utilized it a lot from our recent Minnesota grant project, where we helped a couple of companies find some safer solvent and solvent mixtures to be able to replace transfer applications, specifically with coatings. And Gabriel can kind of talk about that a little bit more, and how he sees he may be applying that to different applications. But a major area to which I've been focusing on for the past couple of years, not just due to the pandemic, but also just from the multitude of different applications for sanitizing and disinfection from both the food and beverage sector, but also in different areas of disinfection that did come out of the pandemic, where we were seeing a lot more companies developing different types of antimicrobial coatings. And we really wanted to ensure that we were hitting that area to provide safer products and actually see what they did with worst case scenarios. So when the pandemic first happened, we actually were looking at different products to see, well, what happens when you don't use it the full 10-minute dwell time? What happens when you only do it for 30 seconds? And how does that compare to bleach or even quaternary ammonium compound products? Some areas of interest that we are looking into getting into a little bit more is the perfluorinated compounds and PFAS. Specifically, we've been trying to build up information on how potentially it's being used within manufacturing. And we understand that some of you may not even know if you are using it in certain applications with certain products that you're using. If you're interested though, feel free to reach out because we would love to talk to you about how we can possibly assist you, whether that be doing assessment to see if you're utilizing PFAS or if we can find safer alternatives for you for certain applications. Specifically, one low-hanging fruit we are looking at is the fume suppressants for hexavalent chrome applications in metal finishing. So we do have alternatives already set due to our research program manager, Greg Morose. We are also interested in looking more into flame retardants, which that is what Gabriel can kind of expand on if you'd like to during his part of this conversation as well. And we're looking into starting a campaign that is a drive to zero. So we have been working actively with those that have been utilizing halogenated solvents in the larger scale amount of use. And we are close to about 5 of the major companies here in Massachusetts that are still currently using TCE. So we are going to be tackling each one of those major ones, TCE, perchloroethylene, and propyl bromide, and also any of the transdichloroethylene products as well. We want to ensure that we are looking at these and methylene chloride for safer alternatives to be able to help us become free of having to use these halogenated solvents for our applications while still promoting manufacturing. As you can see here, I put in a QR code for you guys as well. In case you didn't know anything about it, we actually do have an alternative to halogenated solvents used in surface cleaning. And what's great about this guide is it really walks you through what even TURI does to work with different companies. So if you don't have a starting point or don't know what alternatives are out there or even how to assess different alternatives, this guide can really help you kind of delve into what questions you may want to ask us, or even you as working with other companies on how to even start asking those questions to them. And if you ever need any answers on how to utilize this or implement this, we're here to help you. And just a reminder, we do offer free laboratory services to companies in Massachusetts. And that's something that you can always reach out to us about what that means, what that entails, and how we can help you. For this part, we're also going to quickly talk about the future of toxic reduction. Recently, we really invested into thinking about how we could expand finding safer alternatives beyond just assessing and really finding someone who may have that expertise. So we just hired a green chemist on board to our staff. We also are really trying to get more into solving those toxic reduction roadblocks and listening to you and what your needs are. And we understand that every scenario when working with a company is really individual. Even though you may be in the same sector, your needs may be different than another company's, and we understand that. And then we're really wanting to start building capacity for the next generation, which you're going to hear about when Amelia is talking a little bit about how we're trying to engage students and potentially set up programs to allow them to work with companies one-on-one for more bandwidth assistance. So I'm going to let Gabriel have a moment to introduce himself and talk a little bit about his goals and current projects.
Gabriel,
Okay.
you're, oh, there we
Hi.
go.
Hi. Gabriel here. Well, I am a chemist by training. I have a PhD in industrial chemistry, and then I work in a few postdocs on green engineering, clean energy based on biomass. My area of expertise is mostly chemical reactor engineering and unit operations and analytical chemistry. I am passionate about green chemistry and finding ways for cleaner production. And well, currently we are trying to help companies to phase out the use of chlorinated solvents for degreasing purposes. For that, I am doing a systematic study on alternatives, and also considering solventless approach. Not needing a solvent for degreasing. Also, I am working on feasibility analysis on different equipment. And other alternative would be a closed loop solvent use if there is no good alternative. And then my goals as green chemist is, of course, making green chemistry and circular economy feasible for Massachusetts industry. And we are launching a campaign, or we are planning a campaign to address also the use of flame retardants, and also finding alternative flame retardants, and also trying to find alternative flame retardancy approaches. So the idea would be on first place, trying to find safer chemicals, and also trying to see if we can meet our ends without chemicals. That's another point of view I am trying to contribute. So happy to help. Anyone can reach me out.
Thank you so much, Gabriel. And now we're just going to take a quick moment to allow Amelia to tell you a little bit about a recent grant P2 summer internship to which she participated in, and that will lead into actually the work that CEDAR has been doing. So I'll let Amelia talk a little bit about that.
You're on mute.
There we go. Sorry. I'm Amelia, and I'm a lab assistant with TURI, and I started with them in January when I was in my last year of my undergrad program. I recently graduated from UMass Lowell with a bachelor's in public health, and I completed the P2 summer internship at CEDARS. And the internship is basically a program that was funded by the EPA with a grant to send students on site to different food and beverage manufacturing facilities with the goal of identifying different areas of waste, whether it's solid waste, energy, or water waste, and then researching and testing out potential solutions. I can go to the next one. So some of the things that I worked on at CEDARS, I started looking at food waste and trying to identify where it was coming from and how much there was. And then my other main project was looking specifically at the cleaners and sanitizers that are being used for the clean in place process to clean out the big mixing and pasteurization tanks. So I did a lot of observation and research trying to figure out what's in those cleaners. There was some sodium hydroxide, sodium hypochlorite, potassium hydroxide, some things that would benefit the company and the environment and the workers to either reduce those things or cut them out altogether. And then I was able to look into different avenues to try, like maybe an enzymatic cleaner or a chlorinated base cleaner or lactic acid sanitizer. And I was able to bring all this information back to the TURI lab and start testing out these different ideas with products that had previously been implemented successfully at other food and manufacturing places. And so I did a lot of performance testing to see if these different alternatives would measure up to the current performance that's happening at CEDARS. And then I produced an overall final report looking at kind of the economic analysis of these different alternative cleaners and seeing if it's a feasible option to continue researching in that direction, or you know, does their current vendor have products similar to these, or would we look elsewhere? And I'm continuing testing as well this year.
Thank you, Amelia. So the reason why we're actually highlighting this is, although we do currently have students working in the lab, and they do participate in doing a lot of the laboratory testing that we do here, which not only allows them to engage and understand how complex manufacturing is, but in understanding where certain things come from or where they're made from and how that relates to their background, to be able to expand and think about toxic reduction. We are interested in potentially doing something like this again in the future. So although this summer internship is not available right now, this may be something we want to explore going forward. So we definitely would love to hear your feedback of whether you would be interested in us looking for continued funding to be able to provide a student that could actually come on site to be able to assist your facility and do sort of the things that Amelia talked about and what Lisa will go into further information on, and also expand upon what her experience was with this P2 internship. Awesome. And with that, so we're going to actually start getting into the case study summaries.
But first, we're going to do a quick poll. Sorry,
No,
you
it's okay.
for me. Yeah, okay. So just following up on what Alicia was just saying, you know, we have a little poll here. It's a little bit different from what you're used to seeing. We're trying to just gauge your interest in working with TURI in a number of different ways. And so if you could go ahead and complete that poll, that will be really interesting for us. Are you not interested? Are you fairly interested? Or are you very interested in some of the things you just heard Alicia, Gabriel, and Amelia talking about? The polls are also a way that we can demonstrate to DEP that you're all paying attention. So there's that. So go ahead and participate. It looks like we got about 3/4 of you already responding. That's terrific. I want to give it, you know, another few seconds to get everybody participating, and then I'll share the results. And this is really helpful. Great. I'll give you just another second or two. Okay. Well, thank you all. I'm going to go ahead and end this poll, and I'll share the results with you. As you can see, we've got a fairly even split of interest in working with the lab on testing the performance of safer cleaners. Fairly even split, perhaps more towards the very interested side of working with the lab to develop safer alternatives to solvents. And that's great. There's a real interest in that, and there's certainly a need for finding safer solutions to solvents, and that's been a focus of our research for a number of years now. Funding for implementing toxic use reduction techniques, and finally, you know, a little bit of interest in summer interns. So what I'll just stop sharing, and then just, you know, encourage folks, if you are interested in any of those things and want to follow up, you know, feel free to reach out to Alicia or Jason or me. And you know, we're happy to kind of work with you. Absolutely. So Alicia, are you done?
Yes, I am.
Do you
So
want to stop sharing, and then I'll go ahead and I'll share, and you can introduce Lisa while I do this.
sounds good. So our first person that will be talking about their case study will be Lisa Lyons. So Lisa is from Cedars Mediterranean Foods, and I will leave it up to her to start with her presentation and tell us all about it. Thank you so much for coming today.
Go ahead, Lisa. I'll just follow your lead.
Okay, there it is. I'm I'm the Health, Safety, and Environmental Manager at Cedars Mediterranean Foods in Haverhill. I've been with the company about a little over 4 years. And you can see there on this first slide a variety of the products we make. We make so many kinds of hummus, I can't even count them. We also make our own and incorporate that in some yummy dairy products, some dips. We have a salad department. We make other dairy, and we do a lot of co-packaging for all kinds of grocery stores and other companies. So there's a lot going on at Cedars these days. And we're trying to work with the TURI Lab. What I'm here to work with the TURI Lab to try to find some safer cleaning and sanitizing alternatives. So I've done some work with the OTA, Office of Technical Assistance. So I want to put in a blurb for them. I had landed here at Cedars in July of 2018, and in the fall of 2018, we invited OTA to come in and take a look at our environmental programs and see what we could work on and possibly do better. And that was a very beneficial experience. So I would recommend that to anybody who's, and that was free. A couple people came in and gave us some ideas on things we might need to look at for our air emissions, some ideas for water conservation. And they also said, hey, you should take a look at this Kettle Cuisine case study. Kettle Cuisine makes soup in stainless steel tanks, and we're making hummus in stainless steel tanks. And we're using sodium hydroxide also, and they were interested in finding some safer alternatives. So I read the case study in 2018, and that's what kind of started the idea that I've had in the back of my head for 4 years to maybe work with the TURI Lab someday ourselves. We currently use a lot of sodium hydroxide and some other chemicals. I'll give you more information about that in a minute to clean our tank systems. So from left to right here, we have homogenizers that make the chickpeas all uniform. And then that goes to batch tanks, the second photo there, where they open that little porthole and add flavorings and seasonings to make all the different varieties of hummus. Then the third picture there is one of Cedars' claims to fame is we pasteurize our hummus. It's not raw hummus you're getting. It's been pasteurized. So our customers love that it has a shelf life of 60 days. So that's fueled our growth, I think. And the fourth picture there is a holding tank. We have a lot of those, and that's where the finished hummus gets held in a chilled environment until it gets pumped into a container and a filler. So I took a lean manufacturing class. I got an email from TURI, said, hey, we have one spot left in this lean manufacturing class for food and beverage manufacturers. And this was free. And I said, wow, are you kidding? I would love to learn more about that. So I signed up and then went downstairs and asked my boss if that was okay, because I really wanted to take advantage of this great opportunity. That was a wonderful class. And that was free to the 10 people who participated through an EPA grant that Joy Onash, who was working at the TURI at the time, got from the EPA. And then after the class, Joy got another EPA grant, and she said, hey, would any of you who took this lean manufacturing class be interested in hosting a pollution prevention intern? And I said, sure, I would. So we ended up having a good experience with Amelia Wagner that you just heard from a little while ago. And she worked for us for 12 weeks in the summer of 2022. And that was great because of the EPA funding. We had to cut her a final check of $586. So we had her on site for 12 weeks for the bargain price, thanks to that. So another wonderful thing we got for free because of TURI's work with the EPA. So she was initially started working on documenting where some of our food waste was occurring. But you know how it goes when someone with a clipboard is watching you, you might not be doing the same things you're doing when they're not around. So it didn't seem like anything was materializing for her that would be a good project for her to get into over the summer. As the summer wore on, she told me that she had TURI lab experience. And I went, what? wow, that would be so great if we could get something going with TURI and switch directions, maybe from food waste to safer cleaning and sanitizing. So she filled out the TURI lab application, which was not very long, just a couple pages. So don't let that stop you from trying to work with TURI. That was one of the things that had kind of stopped me. You know, we're all so busy, and when if your company's growing and you're getting into a million different things, I'd had the application and just hadn't filled it out. So my intern did that for us, working with us to get all the information. And then she actually began working during her internship with Alicia in the TURI lab on doing a first round of evaluating safer cleaning and sanitizing alternatives last summer. And that work is still ongoing. And there's Amelia Nye down there in the corner. Okay, the next few slides I took out of Amelia's presentation, her final presentation to us. Love that the water droplets in the corner. I thought that was great. So this is a baseline of what we're using on the left, the chemicals that we're using. And on the right, we won't dwell on this now, but these chemicals, you know, sodium hydroxide, potassium hydroxide, sulfuric acid, a lot of severe chemical health implications. We do use diluted forms of them often, but still, any reduction or replacement of these would be beneficial. And here's Amelia's lab setup. So on the left in the picture, you see the sample coupon she's working on. We used 304 stainless steel and 316 stainless steel because that's what our tank systems are made out of. And we used chocolate hummus because we figured that would be the one that would be the hardest to get off. In the middle, you can see she's got her ultrasonic setup there. So she's using different cleaners and different temperatures and ultrasonically agitating the coupons to see what kind of results we get. And they were looking at gravimetric visual and an ATP measurement to see how clean they got it with the different tests. And as she spoke of, they evaluated different cleaners, an enzymatic cleaner, lactic acid, PBW is actually something that's used in the brewing industry, and then some alternative sanitizers, lactic acid, and some other things there. And there's those sample coupons. So we have blade scrapers inside of our tanks that scrape off most, but not all of the residual hummus. And she did a pretty good job, I think, of replicating that, just kind of leaving a little bit on there, but not too much, because the blade scrapers get most of it off, apparently. Based on the initial round of testing, Amelia recommended replacing 5229 AFCO, the one with sodium hydroxide and potassium hydroxide in it, with an enzymatic cleaner, replacing the 5229 AFCO with PBW, and replacing the 4325 Perox sanitizer with the lactic acid sanitizer. There's a lot of testing you can do, because once you find some things that work, of course you want to play with it, alter your concentrations, temperatures, and the goal is getting something that works and using as little of it as possible at the lowest temperature possible, so that you're saving energy and saving chemicals as well. And then we also wanted to talk to the vendor, find out, our current vendor, find out what enzymatic, lactic acid, other solutions they may propose. One of my bosses once said, it's easier to do something with someone than do it to them. He was talking about safety, but it applies to a lot of things. And I wanted to include our current chemical vendor in this process. And I did a little education with our local rep. And then on the next slide, Alicia and Amelia had a hour-long phone call. I think the regional vice president or something from our chemical company and also our local rep met with them, and they discussed different alternatives, and AFCO provided them with information on some different products that they had. And then this is a great table here that Amelia just gave me recently. So they put all the safety information on these different alternatives into the P2OA analysis and got different scores. So the scores were in all different hazard categories. And then down on the bottom, there's a kind of a weighted average. And you can see that I think the highest score was 7, the highest weighted average in some of our current products. And there were a couple alternatives that went down as low as 5.1, 5.4. Not huge reductions there, but a little bit. And this gives you a lot of information to consider because your site may have certain things that you're more concerned about than others. So I like the fact that it gave you scores in different areas. So where we are right now, you know, we didn't get any chemicals that had a hugely better score, a little bit. Some had comparable safety scores, but perhaps greater dermal toxicity or some other property that we really wouldn't like. So we're still chewing on that data, and we need to meet as a team here at Cedars and deciding which of these chemicals we'd like to test from our present vendor, or do we even want to think outside the box and give TURI the green light to test a few chemicals from other vendors that may work? And after that, if we do further testing with TURI and some solid alternatives emerge, the next phase, of course, would be pilot testing, trying a different cleaner and a different sanitizer on one of those tank systems that I showed you in the previous slides and seeing how that works. So we're excited to continue this journey with TURI and work with Alicia and Amelia. We appreciate their help.
Thank you so much. And for everyone who may have questions, we're going to hold off on them, but please place them in the chat and we'll definitely collect them. And that way we can bring them up in case if you forget and you just want to get those thoughts on there. Our next speaker is going to be from SE Shires, Chuck Shepard.
Yep, sorry, hold on a second. I'm
sorry.
getting to the share my slide chart.
No worries.
Okay. Take it away, Chuck.
All right, good afternoon, everybody. Again, I'm Chuck Shepard. I'm the Director of Safety, the HR liaison. I'm an EMT, a master craftsman. I've been working at Shires for 27 years since we began. I'd like to talk a little bit about what we do as a company and kind of where we are going, and talk about some of our challenges cleaning wise today, and kind of how we're going about that. Shires, if you go back a slide, yeah, go ahead. Shires was bought, Eastman Strings bought us about 8 years ago. We became Eastman Brass Instruments. We started 27 years ago in my brother-in-law's basement in Midway, Massachusetts, not too far from our Holliston facility. We make custom trumpets and trombones primarily. We're dealing with kind of higher end instruments. We've got trumpets and trombones in a lot of the major orchestras throughout the world. Some other venues like Mike Davis with the Rolling Stones, Bobby Burns with Earth, Wind and Fire. We've got a trumpet player in the Celine Dion band, Toby Keefe. I could kind of go on and on. So quality, we built the company on quality, and fit and finish is really important for that. So because of that, cleaning has always been an important factor in what we do. We started out with aqueous and had a lot of trouble with that. We didn't have the resources to really follow through with that. So then we switched and converted over to a vapor degreaser with trichlor. And
So Chuck, before we go any further, Do you want to show a little bit of the video that demonstrates kind of where those challenge areas are?
Yeah, we could go. There's two clips here. The first one, I'm going to play that.
I will play that in just a second. Okay. So this is really interesting. It gives you an insight into where their challenges lie. And in between each clip, Chuck, you can kind of talk about why that's a challenge.
Yeah.
After the ice melts, he places the U-bend in a balling out die. He lubricates the tubing with oil and places a steel ball at the top of the tube and presses it down. He drops in smaller balls and they push the first larger ball through the U-tube. This stretches the inside of the tube, rounding it to the correct diameter. And then the balls exit at the other end. Now he pieces.
In that clip showing the balling out of a tuning slide crook, one of the challenges we had with that was the carbide balls seizing up in the brass tubing as it was being pushed through there under pressure. And so we had to use a lubricant that was really sticky and prevent the balls from grabbing the tubing. So the vapor degreaser, it was fairly easy to clean with aqueous. We had some difficulty. One thing I will mention that in the transition from solvent degreasing to aqueous cleaning, we've also taken some steps to kind of change some of our processes and some of the things we use for those processes, like the lubricants, finding lubricants that are more aqueous friendly, buffing compounds that are water soluble. And in the next video clip, you could play that, Pam, we'll see yet another compound that's difficult to deal with.
Diamond tip tool engraves the company logo onto the trombone's bell stem. And a cloth buffing wheel spins against the trombone flare to polish it.
Now, the compound that's used on that cloth wheel is an abrasive that's embedded in a kind of a wax, greasy compound, almost a solid compound, and it tends to be very sticky. And I'll talk a little bit more in a couple of slides about some of the difficult parts and specifically some of the challenges that we had with that.
And you know, the slides are on our website, and I really recommend that you go to this YouTube site and watch the whole 5-minute video. It's fascinating.
So there's the old beast, our first vapor degreaser that we used for about 20 years. I mean, we had some challenges with vapor degreasing, getting things clean enough. So that was not certainly a panacea. As that machine started to die and we became more concerned about some of the health risks that were associated with trichlor and a machine that wasn't fully functioning, we started considering aqueous cleaning. And we made a transition while we were still using vapor degreasing into aqueous cleaning, and did a lot of R&D work in-house to get set up. As we were experiencing more difficulty with that, I should also mention too that we were working with the OTA, the Office of Technical Assistance. We've consulted with them on several other projects over the years. And they gave me the information and referred me to the TURI cleaning lab about, I think, 3 years ago, Alicia, was it? Or it was pre-pandemic?
Yep, I think it was 2019.
Yeah. As we got to a point where we were kind of our R&D capabilities were kind of stretched to the max. So the TURI lab was able to take on the project, even given their constraints at the time with the COVID pandemic. And we came up with a cleaner that we're using today that works very well. There were challenges with cleaning several parts, like this bell with the engraving, where the buffing compound tends to want to kind of stick in the engraving. The circumference of the bell bead, which isn't in the photo, was another point of difficult cleaning, even for the vapor degreaser. Although we've had challenges with cleaning with the aqueous cleaning, I think have a higher success rate with cleaning with the aqueous than we did with trichlor in some ways. We're able to get like these bells cleaner because we have ultrasonics. The Kaizen metal Knox works really well with buffing dirt and some of the other greases and compounds that we have to deal with. We have kind of two types of cleaning that we do. One is the cleaning, I guess for us, it would be critical cleaning for the finishing. A lot of our trombones have a clear sprayed on lacquer finish. Our trumpets, for the most part, are silver plated, so cleaning is really important in order to get a good finish that will adhere and will actually last. There's another type of cleaning we do for final assembly where we have to be mindful of the fact that the lacquer will come off in an ultrasonic tank when the temperature is elevated. So we have to have a little different chemistry, or a little different chemistry and a lower temperature in order to be able to work with that. As you can see here, the metal Knox is what we're using for our first stage cleaning in that first column. The matchless in the middle column is what we came up with on our own and learned through the work with the TURI lab that it probably wasn't the most ideal cleaner for us, given the health effects that you can see in this. And then on the third column, you can see the trichlor is kind of matching the matchless in three categories. Our second stage cleaning for the kind of the critical cleaning, we're using a Tesh classic brass. We just had been experimenting with and are using that for just the lacquer prep and silver plating preparation. So we use 3 different cleaners, and we've got 5 different cleaning tanks. I should also mention that one of the other reasons for changing from, or making that transition from solvent-based cleaning to aqueous was the expense of the solvents, in addition to being concerned about kind of the health concerns. The solvents was expensive, and the disposal and handling of it got expensive as well. So moving forward, we were able to apply for and receive a grant through the TURI, I guess through the TURI lab, through Joy Onish last year. And we just received 2 90-gallon ultrasonic tanks this summer. And even since these slides were set up, we just got the 2 tanks up and running yesterday. But that grant really gave us the capability to be able to expand what we're going to be able to do next year. We'd like to be able to add some larger instruments to our mix of custom instruments. We were able to also obtain 2 more rinse tanks to go along with this. So I'd like to give a real plug for the TURI grant process. It was really, I'd never written a grant before, and it was very doable, and it was really helped us tremendously. We'd like to be able to reduce the number of cleaners we use just to simplify things. We'll be doing some more work kind of in-house, and also with the TURI lab, with the cleaning lab on that. Rinse water quality issues are something that we're still struggling with. So we'll be dealing with that ongoing. That's another project where we're also consulting with Jim Kane and the OTA has been very helpful with that. But our bigger focus has been getting the cleaning tanks set up and identifying the cleaners that we need to use that actually will work for us. We just started using the metal Knox this summer, and have a pretty good track record with it so far. So we've made the switch from solvent to aqueous. Been a lot of challenges. It's taken us 5 years to do it. I think we're in a much better place with quality of our fit and finish. If anybody has any more specific questions, I'll certainly be glad to try and answer them when that time comes. And I want to thank Pam and Alicia and everybody at the lab and the OTA for all the help that you've given us over the past several years. Thank you very much.
Okay, thank you so much, Chuck. And then for our final speakers, it's going to be from Berry Industries. We have Brian Triano and Kevin Schmidt that will both be co-presenting. So take it away, Brian.
Hey, thanks, Alicia. Okay, Pam, you got this? Okay, cool. Okay, so yeah, thanks everybody for this awesome opportunity to share what we're doing over here at Vishay. It's very exciting for us. So basically, as you all know, we're eliminating, and specifically on our site, the use of trichloroethylene. So maybe a small testament to the EPA, but as well as basically just an initiative to improve safety here at the factory. We really wanted to get away from this chemical. And I mentioned the EPA because not only is TCE getting harder to source a good product, it's also there's more cost associated with using it on site too. So yeah, so right now, basically multiple departments in our facility, or recently multiple departments in our facility were using the TCE on site. So for example, here we have assembly, we have our machining department, and also we have a laser cutting department where we cut ceramics for our electronics components. We have two 600-watt lasers on site here. And basically everything, almost everything, every department was going through the TCE at some point. So at our next slide, Pam, you'll see our current, everybody's seen a vapor, oh, this is our current process. Sorry about that.
Yeah. No,
so basically we just want to give a quick overview of mainly what we're doing here. So we're manufacturing electronics components, high power applications. So like resistors, attenuators, flange circuits, some QFNs. So this is basically the we're seeing the final assembly process here. And so this is kind of a final assembly product that will then normally would have gone through the vapor degreaser. That cleaned off of fluxes and little solder beads that got stuck where they didn't need to be. Kevin, you have anything to add about that?
Just that within the changing into an aqueous solution, we're also working on changing our soldering process to go from a rosin flux to a water soluble flux. So what we're looking at in this image actually is our prototype of our two-stage hot plate that we needed to use to do a slower ramp up of the solder reflow temperature to not experience some spattering of the equipment. And I thought it was interesting that it was perfect timing to be looking into aqueous solution where the water soluble flux doesn't clean off very well within TCE. So this is really becoming a win-win for us.
Right. Cool. Yeah, thanks. So if we go to the next slide here, Pam. Awesome. Okay, so now we're going to see, so this is obviously the vapor degreaser that we're using. And right now we're no longer using TCE at the moment, but we switched to another fluorinated solvent. And this vapor degreaser technology is basically, it was designed around TCE. So we're using another solvent in it that it's not really designed for. And although it's a safer chemical, we're wasting a lot of material that's coming out in vapors, it's coming out and potentially harming the operators. So we're really working with TURI to try to get away from this technology whatsoever. But this is what we have. This is what we have now. What we're trying to get away from. So this is the unit that multiple departments were using for their cleaning purposes. So if you go to the next,
which created another problem of mixing types of soils. So it wasn't just the stuff from assembly, but you had using this chemical, but you were also mixing the contaminants as well.
Yeah, there was some contaminants use that we were getting where there different things we were cleaning off our final assemblies, were mixing together and causing undesirable effects. But so I basically just want to go real quick the steps we took to get to our new solution. So the number one, we worked to actually eliminate the vapor degreasing step where we could. So we took it out of procedures where we determined that didn't actually need it. So from a cost-effective standpoint, I would say this is probably the cheapest solution to start with.
Yeah.
It's just stop using it where we don't need to use it. After that, we collaborated with all the experts at TURI. It's such a daunting task to say, okay, don't want TCE, but we got to go to something else. What the heck else are we going to use? So we started with TURI, allowing them to give us recommendations, working with back and forth about our processes and what we could do. We have eventually identified that we're going to go to aqueous solution. After we figured out what the best aqueous chemical we're going to use, then we started adding things like heat. We started adding agitation and ultrasonic and also pressure washes and things like that. And now we're working on formalizing a feasible solution for the end.
And when we figured out what we wanted to do, where Jason had linked us up with somebody with Zestrin, who they helped us dial into the equipment we wanted to buy for this machinery that could use the new chemicals and the new procedures and help us out with that. So that was another
Right.
great thing we got from TURI was help with machinery.
That's right. Oh, if you go to the next slide, Pam, that'd be great. Cool. Okay, so as part of our final solution that we were coming up with, one of the things we ended up doing is we had, instead of a central solution, a central location, a central solution for all the departments to use, we ended up having smaller setups that were then individualized for each department. So that means what we could do is cater the cleaning technology or the cleaning design process specifically for the process that was using it or the department that was using it. That way it would be not only more cost effective, easier to maintain. Each department can maintain their own setup as needed. And also they have their own customized solution that will hopefully work better than the TCE itself in the end. And also another thing in terms of productivity, that means each operator from other departments won't have to travel to other places in the building in order to have their cleaning needs met. So that's a big win for us.
Sure.
Cool. So basically in conclusion, thanks to TURI Labs and also props to Alicia for helping us get started with this whole transition of using harmful chemicals in our facility. We really appreciate this opportunity and we're very excited going forward to even go beyond eliminating TCE and also eliminating other harmful chemicals in our facility as well. So,
Great,
yeah.
thank you so much. So now we're going to open it up for the panel discussion. So if anyone has any questions, feel free to kind of ask now. You can raise your hand or put it into the chat. We do have some follow-up questions for our speakers. Pam, would you prefer if I start asking questions or would you like do you have questions ready from the chat?
Yeah, no, why don't you go ahead, Alicia, and I will, we had one comment, Sandra was just asking about the PBW that Lisa was talking about. We also, Joe pointed out that the fluorinated solvent that you guys, that Brian and Kevin, you were talking about moving towards likely contains PFAS. And as we all know, PFAS is an issue right now. We're all trying to figure out where are the PFAS chemicals being used. So Sandra has a question here. Any cost differences for the new cleaner that replaced TCE? I think that's a question for you, Brian and Kevin.
Yeah, sure, I can speak to that. So basically the dichloroethylene that chemical solvent they're using now is really just a temporary, it's like a Band-Aid.
It was a stop loss. We couldn't get good TCE that was stabilized anymore. So we had to go to something that could at least get us from where we were to where we're trying to go.
That's right. We had to go with the lesser evil in the meantime, because we just weren't ready with the aqueous solution yet. So we are planning to get rid of that as soon as humanly possible and really basically just get rid of the equipment altogether from our facility.
Mm-hmm. And I think Sandra also had another question too. It was specifically for Lisa. Lisa, did you have any FDA constraints that you had to think about too? And while we're going through this process that you'd like to talk about?
We did involve quality. We're involving quality in the process, but basically we just needed to get down to a certain ATP level. And I don't know if that's an FDA regulation or not. But we need, we had a level that we needed to get to know that there would be almost no material left in there. So then you'd know it's clean enough to make another batch and it'd be safe.
Great, thank you. And wondering, Sandra, if this is for everyone, but at least going back to Brian as well. I think Sandra also wanted to know if the aqueous cleaner was more costly and if that's possibly part of that kind of interim step.
I mean, from what we're seeing right now, the aqueous cleaning chemical that we're looking to go towards is way cheaper than TCE, and especially more cheaper than the dichloroethylene product that we're using now. So it's really the equipment that is what is incurring most of the cost. So with the help of the grant, we're able to purchase new equipment that will then utilize the new chemical, but the new chemical going forward should be cheaper down the line.
And with getting this new equipment, there was a decent enough lead time. So even though we put in the purchase order for it in July, we're expecting to get it on site in December and then roll it out into use in Q1 of next year.
Great, thanks, Kevin.
Chuck, was that your experience as well with the aqueous cleaner?
Yeah, it was certainly a lot less expensive. I don't know what the current cost of TCE is nowadays. But the disposal was expensive. Just handling it is a cost. It's just nasty to deal with.
So it's interesting, you're all talking about, the quantitative information, right? Going to a safer option, going to a less expensive option, but there's also all these qualitative issues that really impact the decision. Having your workers feel like they're in a safer work environment has a great value, right? So it's great to hear that. Alicia, while I'm talking, I'll just read this other question for Chuck. So the question, Chuck, is by using more aqueous solution to clean your brass instruments, did you run into a problem with chelated copper in your wastewater?
No, we ran into a problem with lead. Copper wasn't an issue that I'm aware of, but lead has been a problem. And that may go away because we've been transitioning from lead solder to non-lead solder over the past probably 4 months. But we really only have one ultrasonic tank that is deemed as hazardous waste when we're done with it because of the lead contamination. But we do test for that and make sure that we're disposing of all the solutions correctly.
Great. So thank you. So Alicia, go ahead, and I'll keep an eye on other questions in the chat.
Great. So this is a question for everyone, but you talked about your experience, but if you were going to talk to anyone else here in this session, what are some challenges, unexpected challenges that you didn't expect or didn't think about as you were going through this process of finding safer alternatives that you might want to recommend for other people to think about going forward?
I can speak to that just for a moment.
Sure. Thank you.
I think it was, and I think maybe Brian might have mentioned this too. It's the kind of the lead time, the transition time that it took. And we tried to use trichlor for a while during our transition time, but I didn't realize it was going to take this long to get to the point of getting the quality cleaning that we needed or were desiring. So time and kind of resources, I think, were a little unexpected. I should also say too that what was unexpected is that in the end, the quality is better than what we had with the trichlor. So we've ended up in a better place.
That's awesome. Thanks, Chuck.
Lisa or Brian and Kevin, do you have any response to that question about challenges?
There were a few interesting ones where one that you mentioned sort of where it's just not how my brain necessarily works, but when somebody was asking like, well, what's the odor on these new cleaners? I'm like, I don't know. I'll have to check it out. And it just turns out that, that was certainly a benefit where, it's much more pleasing environment to work with it. And then also where I'm usually involved in quote contract review and stuff like that, something I didn't consider on looking at this to begin with was, finish requirements when we ship them to our customers, including our military specifications, and making sure that we didn't leave any residue that wasn't going to adversely affect on their end, and also certain parts of things where we have copy exact, or if we don't have material review board authority on the final product. I didn't think of this ahead of time, going over this with customers, that yes, we're making a change in our process of how we develop it, and we also need that to be green lighted by our clients as well.
And have they green lighted it?
We haven't had any problems yet, so we've been good. We should, been no problems with that. We're having more difficulty with aqueous, or not aqueous, sorry, that's not the issue. Water soluble flux, where that will have a little more trouble with changing of the final material, but so far there's been no problem with cleaning.
That's great. That's great. Lisa?
Yeah, I'll piggyback off that comment about the clients, because we have, I'm usually not involved in them, but our quality department hosts our customers like weekly, it seems, and other customers there. So they're all going to want to audit all these processes, and they're always looking at our sanitation procedures. So quality is definitely going to be an intimate partner with us in making any changes. So we'll make sure that we're keeping everything safe and keeping our customers happy.
Great. There's a couple questions in the chat that I'll just follow up with you, Lisa, on. So John asks if you've considered using hypochlorous acid as a cleaner or sanitizer, which can be created on site from sodium chloride solution. And it's a question for you as well, Amelia.
That sounds neat. I have never heard of that, but I will certainly check it out.
And
And
that, oh, just
Amelia,
to
have
add a
you
little-
looked at the NADCC tablets for this?
I did test those out as a sanitizer. And from what I can remember, they worked fairly well, at least equally as well as the current sanitizer.
And that generates a hypochlorous acid solution, correct? So you
Yeah.
have looked at it. Okay, good.
Okay.
And yeah, right? There's a lot. So which cleaner did you find works best, Amelia? The enzymatic, the PBW, the lactic acid, or were all specific to the types of metals that you're cleaning?
The enzymatic cleaner and the PBW both worked very well, actually slightly better than the current product. So that was really interesting to see. And the lactic acid didn't work so well as a cleaner, but it worked as a sanitizer. Yep.
Mhm. And Sandra follows up with a question, which is a perfect toxics use reduction planner question. What about non-chemical cleaning approaches like pressure washing or steam? Is that something, Lisa, that you think would be an option?
Well, you saw all those things that are connected by various pipes. It's kind of a complex system. And basically when they're done, when that final tank is empty and they're ready to clean everything up from the homogenizer to the filler, they hit a button on an HMI screen and the process begins. So it's got to be something that pipes all the way, it's got to be pumped through all those different components. So I don't think steam would work. And I don't know how you would pressure wash the inside. You're basically pressure washing by pumping the water under pressure. So we're kind of using that already. but steam, I don't think would be a good option.
It kind of raises another question or another observation. I think both Chuck and you, Brian, and Kevin have talked about looking upstream at why do we have to use TCE, and can we be doing something differently that facilitates the use of a safer cleaner, which is a perfect toxic use reduction approach. Looking upstream and what can we change so that it's easier to go to a safer chemical. Do you want to elaborate on that, either one of you?
Sure, I can speak to that real quick. So if you're asking for an example, Pam, is that right? I can give you okay. So one example we have is we also have a plating facility here on site, and for example, we're producing some copper pieces that were part of a final assembly, and they would be at some point delivered to plating, and then they would get plated. And we found out that we were degreasing them here in our department, sending them off to the plating department where they're then going through an acid wash. So it didn't make sense. And even before that, if I go back even further, before we degrease them, we also put them through a tumbling that had a caustic soap in it. So there's 3 chemical washes. So we were able to eliminate the solvent wash, and we didn't really need it because it went to the final chemical wash right before it was plated. So that's one example.
That's a great example. How about you, Chuck?
We haven't really eliminated anything like we don't do the silver plating on site. We send that out. So we're kind of in sync with what they're looking for as far as cleaning. So we're not over cleaning it for them or under cleaning it. It's probably the closest example I can think of.
Well, you've also looked at the buffing compound itself.
Right, gone to a water soluble compound.
So again, a really perfect, kind of toxic use reduction approach.
In our drawing compound, we've gone to a water-based lubricant for that.
Right, good.
Which is safer and easier to handle.
So Jim Curran points out that when transitioning from solvent to aqueous, there may be other permitting issues like wastewater discharge permits that need to be considered in the process of making that change. It sounds like both SE Shires and VSHA are not quite there yet.
We didn't haven't had to deal with that because we're a closed loop system. We don't have the ability or the option of being able to discharge. So we just have to drum everything up and ship it out.
And then a couple questions. So yeah, I think you already mentioned that you're currently using lead solder and are looking to move away from lead solder. We have a question here for you, Chuck, about what the silver plater does to clean the parts if necessary. Are you familiar with that, with their process?
I'm not familiar with their process at this point. They wouldn't, when I visited them the last summer, they wouldn't let me in the facility for a variety of reasons. So they may be using solvent degreasing at this point still. So I really don't know what they're doing.
Well, Alicia, go ahead.
Sure. So you were talking about your experience working with different vendors from, working with the current ones that you have, looking beyond that. How was your experience working with vendors, and how did you find certain products? I know the TURI lab found some ones for you and connected, but I know, Chuck, for example, you found a couple yourself as well that you were interested in. So how did you approach those conversations with different vendors, or know which ones to even go to and navigate that relationship to ensure that your needs were met?
We found some in looking for different products that were easier to clean, like the drawing compound. They also have a cleaning product. So we found things kind of sideways in that regard. We had a gentleman that worked here kind of in the capacity of a production engineer who did the initial R&D work, who did quite a bit of research and found some of the cleaners that we had tested. which carried over into the work we were doing with you. But the vendors were very happy to, offer their cleaning product or information on it, finding things that were compatible for the drawing compounds and et cetera.
And what about navigating equipment too, Chuck? How did you know which one to go with as you went through it, other than through suggestions of TURI? But I know you were also doing some research too for a while.
Yeah. The equipment that we've ended up with has been, we've just heard about through the musical instrument industry. And so working with the vendor, they have experience working with other manufacturers. So we were able to kind of tailor the equipment to something we knew would work because it worked for some other facilities. Although they wouldn't necessarily give us all the details of where it was being used, but we had enough information to be confident that what we were getting would work.
Great, thank you.
How about you, Lisa? How can you expand a little bit on the your work with your vendor?
Yeah, I know that we have a contract. I'm got a question now to my boss. How long is our contract with this vendor? Because obviously that's going to influence whether we want to look outside at other alternatives or not. If we're locked into buying these chemicals for them for a certain number of years, then we're probably going to favor alternatives from them. But I found them to be pretty good to work with. I think they presented us with a lot of alternatives from the chemicals that they sell. So we'll go from there.
And Brian and Kevin?
A lot of the help we got on that was from testing items that were available at the TURI lab. And then we made our connections via TURI to the vendors to get those items on that. And actually, there might be a good opportunity coming in next year when we're getting the system installed, where I think we're going to be getting exposed to a couple more Zestrin chemicals where they think might be more optimal for our operations. So it might be an opportunity for a rep from TURI to come and meet with somebody from MB Tech and or Zestron on that.
Great, thank you. So what do you need the next generation of employees to bring and know to help with continuous improvement? I know, Lisa, you had an experience working with a student coming in, especially with not the normal background for food and beverage, but I guess from even talking to your workers and from new people that you hire, what are you expecting as you go forward to ensure that you're continually looking for toxic reduction opportunities based off this experience? Chuck, if you wanted to go.
Continuous improvement. I think we're just going to have to keep kind of refining the process and looking at the quality that we're achieving and see where we have gaps and problems as they crop up. I mean, we're still not at home plate yet, but we're getting close. So I guess it's just more kind of seat of the pants work at this point, as well as while doing some more work with the lab to try and replace the cleaner in the final assembly tank.
Great. Lisa?
I think for me, it's just constantly trying to educate the employees that we are looking at new things and we're open to their ideas. One of my coworkers who likes to make beer at home was the one who suggested we tried the PBW brewer's wash compound. So just there's so much going on at work and you've got your day-to-day production quotas and everything. So just talking to people as you're walking around about what we're doing and they have any ideas and being open to try. Hopefully they're open to trying new things as we move forward.
Great. Brian, Kevin?
Okay, so I could speak to this so I'm a mechanical engineer myself, so I'm going to speak from a mechanical engineering standpoint. And basically, as an engineer, I'm a problem solver. I need to solve problems, and this is going to be a continuing problem going forward. And any students coming up, they're looking to get into engineering. I mean, this is going to keep coming. There's multiple chemicals. If I brainstorm right now, I can come up with a list of chemicals that we should probably try to figure out how to eliminate in our facility and go with safer chemicals, less harmful to the environment chemicals. I mean, environmental stuff is really a hot topic right now. So I mean, there's an endless supply of work to be done, I would say, going forward. That's my generalized answer. So Kevin, if you want to add something.
And there's also a lot of great opportunities where too often people look at improving environmental things as a sacrifice on some other end of things, where what we've been finding through this experience and is a belief of mine in general that you can generally find a better option that's more environmentally friendly and mutually beneficial to process ease and cost reduction. It just takes a lot of work to get there.
Great, thank you so much. And Beth, I see in the comments is asking, now, for those of you on the step for implementation, do you plan on limiting impact of shutdown during installation of the new equipment? What are your plans for that? And Chuck, if you want to go first, actually.
Yeah, we had probably little impact from installation of equipment. When we initially had the degreaser, we were able to set up aqueous cleaning kind of side by side. And then with the advent of the 2 new tanks that we just got set up yesterday, we already had 3 tanks in use. So the biggest problem was just having the electrician working back there, trying to get everything set up and getting moved around, but we really had very little impact on our production from it. We're able to work around it pretty easily.
You also have a very different product. It takes, what, 50 hours to manufacture a single instrument?
Yeah, 40 to 50 hours to make a trombone and about 20 hours to make a trumpet.
So it's a very different process as opposed to, say, Lisa, where you've got continual, processing going on of food. So, and I imagine with you as well at Vichy, you've got a kind of a bigger production schedule. And so how are you planning on implementing? How is that going to impact production?
Okay, so again, speaking from the perspective of an engineer, so to limit the impact on production, let me start there. So first, to limit the impact on production, as an engineer, and doing the work in the design phase is the cheapest, most cost-effective way to make sure you have the least impact on manufacturing. What I mean by that is, if Kevin and I have all our ducks in a row and we identify the most feasible solution and we can certify that it works before we implement it, that's the best way to avoid a lot of issues. I'm sure there's going to be other issues that we're going to come up, but all the major ones we got to handle before it even gets to the floor. That's what I would say about that. Kevin, you want to follow that up?
And the great thing on this is, as part of making multiple sites to clean closer to areas instead of one place, we'll be running our trials on the new system at a separate location. So until we have those dialed in together to make the new system work, we won't be slowing down our old system at all. That'll be working as is. So one of the largest pieces of work we're going to have on this is updating our routing to reflect the new cleaning system.
Thank you. Lisa, do you have anything to add for your process?
Yeah, I would say we're probably not close enough to a final solution yet, but ideally you'd be just substituting a drum or a tote of one chemical that's less toxic for another. If we ended up coming up with a solution that requires something be generated or made, then hopefully that could be done within the confines of our existing chemical supply rooms.
Great, thank you. So this is a question for all of you again. As you were going through, we talk about toxic reduction planning and really looking at your process as you went through. Was there anything surprising as you actually walked through your process with us or with your planner as you, or OTA, and just areas that you weren't expecting to even address, or little things? I know, like Brian, Kevin, you were talking about there were extra soils specifically in your process that wouldn't normally probably have been there if you were thinking about it, if you were laying out trying to find an alternative. If actually, Brian and Kevin, if you want to go first, definitely share.
Tell you, Kevin.
All right, so one of them was, we just thought of, we have this place and we clean our stuff there, and we weren't really that worried about it. It's like, you clean the system out and you take the stuff out. We didn't think about what was necessarily in there for soils. And then when we realized, we're like, oh, we got this stuff, we got that stuff, and wait, how did that even get in there? Was that part of the bad stabilizing from the TC we were getting? Where I think it helped us get to a point where we're paying a lot more attention to what gets introduced into a cleaning system. And something else we didn't expect while we were working with different methods of cleaning things, for our specific graphite fixtures, ultrasonic cleaning does not work. It pretty much disintegrates.
It pulverizes the material.
Yeah, we had no idea that was coming.
Yep.
That's really interesting. Thank you for sharing that. Chuck, do you have anything to share?
I guess the big surprise we had was the difficulty of rinsing. I don't know if Brian has had trouble with rinse water quality, but that's certainly something we stumbled into and are still struggling with, as I mentioned before.
And Lisa, do you have anything to share so far as you were going through your process?
Well, most of our toxics are associated with our cleaning processes, so that's why we're focusing on that. Wastewater, we use a lot of sulfuric acid in our wastewater, but again, we're using these caustic cleaners, and they're all going to the wastewater. So you've got to balance that out with some acid. So perhaps we'll look at that in the future.
Great, thank you. So I'd like to turn to the audience as well and kind of ask, what opportunities do you see from this presentation that either as tour planners we could potentially collaborate with, or areas that you really need help with that you may have learned from these case studies or just from your own experiences that you'd like to share?
And you can go ahead and just raise your hand or just unmute yourself and talk. We've got, 8 minutes, so we'd love to hear other people sharing their thoughts around what we've heard today.
And while we're waiting for that, there is one more question for you guys from Ted. Have you seen pressure from your customers to reduce or eliminate toxic chemicals? Was that one of the major driving points for switching?
Yes, that's right. Okay, go ahead.
We've seen a decent amount of pressure to eliminate BEO and lead. We're seeing more purchase orders for lead-free or BEO-free or electronic components.
BEO?
Beryllium oxide.
So yeah, some of the electronics components we make use beryllium oxide, and although our military customers may not be that interested in the moment, we do have some customers that are interested in Vishay itself. Our parent company is very, very serious about eliminating toxics on site, and as well as the use of BEO and containing BEO in a safe work environment. So that's something that Vishay is very serious about.
We don't have any direct customers that are demanding cleaner cleaning or anything like that, although the European Union has a ban on lead solder, and at some point instruments that we export will have to be certified lead-free, and I'm not certain when that's going to take place, but that was one reason why we started experimenting and eventually switching to a lead-free solder.
Thank you. Lisa, anything to add?
think a lot of customers in general these days are looking at sustainability and what are you doing about sustainability? What are you doing to reduce your impact on the environment? So another good reason that Massachusetts is ahead of the curve with toxic use reduction planning.
Great, thank you. I see James had mentioned in the chat that depending on the industry, the customer or customers may have to agree with the change to an approved manufacturing process, a potential stumbling block. James, do you feel comfortable expanding maybe from your own experiences of what you've seen, or if that's ever come up that you want to share with others?
Sure. I mean, this may impact Vichy, especially at least in my work with the military. And being in the military, we have mil specs, mil standards that drove certain processes. And so one of the things I was working on when I was in the military is looking at, what requires us, what required them at the time to use or specify certain things. So, and that's not necessarily just the aspect of the military, but other customers, usually when you qualify a process, this is especially with medical products, it involves the FDA. So once you change that, if you want to change that process, it becomes a huge issue. So I just wanted to just throw that out there to make sure people are thinking about that when they want to change a manufacturing, an approved manufacturing process, no matter what the approval is, whether it's a customer, a regulatory agency, whatever it is, that's something that has to be considered.
Great, thank you so much for sharing more. Any other follow-up questions that you have, or any experiences that you want to share that kind of relate to what you've heard today? Any roadblocks that you're facing right now as a tour planner, or resources that you might be looking for?
Looks like Bill, you have your hand up. Do you want to go ahead and unmute yourself?
Yeah, thanks. This question is for Chuck Shepard. Hi, Chuck. What particular issues did you come up against trying to get rid of lead solder? Was heat an issue for you? The extra heat?
Yeah, the heat, the plasticity of it, being able to wipe it, getting a clean joint that you could wipe easily, having it, we're so used to 50-50 lead solder in building an instrument. And we're so used to the way it flows, the way it works, the way you're able to kind of wipe it before you scrape it. It took a little bit to find a lead-free solder that kind of worked the same way, or at least close enough to be able to adjust to it.
Basically a nickel-based solder?
No, it's tin with a little bit of silver and a little bit of copper in it.
Silver and copper.
I could send you the safety data sheet on what we found. I don't remember the exact components of it.
That'd be great if you could. Or put a link to it in here.
I can't put a link in it at this point, but if you want to contact me through Pam, she can get you my email address.
Sure.
Sure, that'd be great. Thanks, Chuck. I
Yeah, you're
appreciate it.
welcome.
And yeah, I mean, same question for you guys at Vichy. I mean, are you still doing lead solder, or have you been switching? You've got a military customer, which is more of that kind of critical use. So how are you managing that process?
Yeah, I'll let the quality guy answer that one.
All right. So we've been getting rid of lead for a while, and we were using some pure tin, and we were running into some issues on that, especially with air and space stuff. There's a problem with tin whiskers. So you want a SN96, and then SN96 would have a little bit of lead in there. But since then, we've been working to get into, like Chuck said, silver, where right now the water soluble flux I'm working on has 96% tin and 3% silver, and then copper as well.
Very cool.
It's, for the most part, only military might still want lead. I can't think of anybody else who still wants that.
So we are just about at 4 o'clock. Alicia, are there any last thoughts that you want to share before we wrap this up?
I think just you know, TURI is a resource for you, as well as not just as industries, but also as tour planners. There's always opportunities where we would love to collaborate with you, or even provide sharing best practices. These are some of the best sessions because we really get to hear from the industry telling us their needs and their stories. And I think that means a lot more than just having us tell you about what we've seen, but actually hear it from them. So I really appreciate Lisa, Chuck, Ryan, Kevin, for really taking the time today to tell your story and answer a lot of these questions, because it was really helpful. Thank you.
Right. Thank you, everybody. It's been
everybody.
a really great session. Thank you all for sharing your stories. Lisa, one comment here, use coffee grinds. They're very abrasive and might be worth trying it in a slurry. Very cool idea. It's always fun to think outside of the box. So this is great. Thank you all for joining us. We have 2 more sessions happening next Thursday. So I hope to see you all there. We'll be talking about beyond the safety data sheet, how do we really dive in and understand hazards associated with the chemicals we're using? And then we're also going to be hearing from OTA talking about how toxic waste reduction planning and climate resiliency can be linked, and what are some of the things that we can be doing. So until then, I wish you all a happy Veterans Day tomorrow and a wonderful weekend, and we'll see you next week.
Take care.
Bye,
Thanks,
everyone.
Pam.
Thank
Thanks,
you.
bye-bye.
Alicia.
Take care. Thank you.
Thank you. Bye-bye.